students, I am Nilanjana Senial. Welcome you all to my channel NS Online Math Classes. Our today's topic is solving of exponential equations using logarithms. And the equation will be expressed in quadratic form. What does this part mean? We have understood that there will be an exponential equation and we will be asked to solve that equation using logarithms. We have to solve. This part is understandable, but what does this second part mean? Okay, let this be a bit of suspense. Let it remain as a bit of suspense for now. You will be coming to know about this very soon. Okay, we will be solving a single exponential equation in this today's session, and we'll be of course having the rules. We will be solving the exponential equations using the rules. So without any further delay, let us start with our today's session. First of all, let us look at the given question. Solve for x exactly. 25 raised to the power of x minus 3 times 5 raised to the power of x is equal to 0. Now let us move on to the rules part. Rule number 1 says find the number with an expression for x as its exponent. We are in fact seeing two numbers in this equation. One is 5 raised to the power of x and the other is 25 raised to the power of x. Which one should we be taking? Or should we be taking both of them? Let us continue reading. It should be having its square form in the equation. Fine. That decides which one to be taken. Because 5 square is 25, which is in this equation, but 25 square is 625, that is missing in this equation. So we have to take 5 raised to the power of x and not 25 raised to the power of x. Represent the number with its exponent by a variable and form a quadratic equation. Fine, so let us come back to this part. We write 25 as 5 raised to the power of 2 because we have to take 5 raised to the power of x and express it with a variable. So first thing that we do is we write 25 as 5 raised to the power of 2 whole raised to the power of x minus 3 times 5 raised to the power of x is equal to 0. Second thing that we have to do is we have to swap these two. 2 goes outside and x comes inside. 5 raised to the power of x whole raised to the power of 2 minus 3 times 5 raised to the power of x is equal to 0. Why did I do this? Because I need 5 raised to the power of x in both the places. Only then can I substitute. Else for 5 raised to the power of 2 I cannot substitute. Now that I am having 5 raised to the power of x in both the places, I can substitute. And it is not mandatory that you have to substitute. If you are comfortable with solving this equation with 5 raised to the power of x, it is absolutely fine. You can solve. Continue and solve this equation. No need of substitution. But there are many students who get confused. That is why I am asking you to substitute. Okay. So let 5 raised to the power of x be equal to a. You can take any other variable as well. Definitely not equal to x because x is already present in the equation. So if we write a in place of 5 raised to the power of x, what equation do we get? In place of 5 raised to the power of x, we will be writing a. So it will be a raised to the power of 2 minus 3 times a, which is minus 3a equal to 0. A squared minus 3a is equal to 0. Now, the equation was this, is this one, the given equation. From this equation, it is not very conspicuous that it is a quadratic equation. But this is our well-known quadratic equation. We know how to solve this. Okay. So let us solve this. Rule number 2 says solve the quadratic equation and check whether you can take both the values. Again a suspense. Why is this part written? Check whether you can take both the values. And by now I think you have understood the meaning of this part. Equation expressed in quadratic form. You have seen how did we express this equation in a quadratic form. Okay. And we will be solving this quadratic equation. And okay, let us first of all solve the quadratic equation, and after solving we may be able to realize what is the significance of this part. Okay. So how do we solve this? We are having a as the common factor between these two terms. So it will be a times a minus 3 equal to 0. So either a is equal to 0 or a equal to 3, because either a equal to 0 or a minus 3 equal to 0. If a minus 3 is equal to 0, then a will be equal to 3. What is a equal to? A is equal to 5 raised to the power of x. So either 5 raised to the power of x is equal to 0 or 5 raised to the power of x is equal to 3. Now can you think of any number as the power of 5 which will be giving you an answer of 0? I think you cannot. Even this is not at all an easy task. What number, when taken as the power of 5, will be giving an answer of 3? It is not at all an easy task. But this is absurd actually. But do you want to argue that, okay, if this is not an easy task, we can also consider this to not to be an easy task as well? Can you give me any proof that you cannot have any value of x which will be making this term equal to 0? Find what happens if we take logarithm to the base 10 for both the sides. It becomes log of 5 raised to the power of x is equal to log of 0. And can you have log of 0? Can you have 0 as the argument? No. Then how do you solve this exponential equation? You have to convert to logarithmic equation. And you cannot have a 0 as the argument of any logarithmic term. You cannot have. Any logarithmic term cannot have 0 as its argument. So this cannot be taken. This has to be rejected, and we can take only this one. This is a cross and this is a tick. Okay, that is why I have written check whether you can take both the values. We are not being able to take both the values. Both the values of a. We cannot take. Okay. Rule number 3. Solve the exponential equation or equations formed from the result of the quadratic equation. Equations means in case you can take both the equations. But over here we cannot take, we have to reject one of them. There is a single equation. And solve it by converting it to logarithmic equation if necessary. Yes, we need a logarithmic equation to solve this part. 5 raised to the power of x equal to 3, and if we take log of both the sides, what should be the base? I have taken base to be 5, and since x is in the power of the argument, x is the power of the argument, it can be brought down to the coefficient place, and the base of the logarithmic term is taken to be equal to 5, so it becomes x times log of 5 to the base 5 equal to log of 3 to the base 5. And log of 5 to the base 5 is equal to 1, so x is equal to log of 3 to the base 5. This is the exact value of x to the base 5. What happens if we take the base as 10? Fine, then it will be, in place of 5, just we will be having 10. So x times log 5 equal to log 3. And log 5 is definitely not equal to 1, so x will be equal to log 3 over log 5. This is with base 10. You can take the base as e as well. You can take the natural logarithms. But since I have not covered the natural logarithm part till now, I'm not taking the base as e. I have taken the base as 10, but you can take the base as e as well. If you know that, then x will be equal to ln of 3 over ln of 5. That can also be written, given as the exact value of x. Okay, so x is either log of 3 to the base 5, or x is equal to log 3 over log 5, or x is equal to ln of 3 over ln of 5. Okay, so students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.